Now let's see some applications of first law of thermodynamics. Okay, so what are these applications? We are going to apply the first law of thermodynamics, which is this main equation dq is equal to du plus dw. We are going to apply this equation in various processes which we have already studied. Let's apply it for isothermal. What is an isothermal process? It is a process which takes place at constant temperature. Now we know that internal energy is basically a function of temperature. So if it is taking place at constant temperature, that is delta T is equal to 0, this will imply that change in energy would also be equal to 0. So according to first law of thermodynamics, dq is equal to du plus dw. Hence no change in internal energy, which gives me dq is equal to dw. So this implies that in an isothermal process, entire heat which is supplied to system is used in performing work done by the system. Let's talk about adiabatic process. An adiabatic process is a process in which no heat enters or leaves the system. That means heat exchange equal to 0. No heat enters or leaves the system. So in this case, dq would be equal to 0. Applying law, dq is equal to du plus dw. That means this 0 is equal to du plus dw. So this gives me du is equal to minus dw, or dw is equal to minus du. Now see this equation. Work done is positive and internal energy is negative. Work done is positive when a gas expands. When a gas expands, what will happen? Its internal energy will decrease. That is why it is negative, and hence it will cool down. So this very well implies that when a gas expands, its temperature decreases and internal energy decreases, right? Okay, next would be, I can rub this part, I guess. So next would be isothermal adiabatic. So let's talk about isochoric. What is isochoric process? Isochoric process is the process which takes place at constant volume. Isobaric is at constant pressure. Isochoric is at constant volume. So again the law, dq is equal to du plus dw. Now we have already studied that dw would be what? pdv. Isochoric means at constant volume. So dv is equal to 0. That means this term would be 0. So I am left with dq is equal to du. So in isochoric process, what happens? Total heat given to a system is used entirely in changing its internal energy. Next, let's talk about melting process. What happens in melting? We know that amount of heat required by a system to change state from one form to another, it depends on the latent heat value. So Q, we have studied the formula, Q is equal to ml. So if I'll apply this law, which is dq is equal to du plus dw, what will I get? Instead of dq, I am writing ml, which is equal to du plus dw is what? Dw is again pdv. But when solid melts into liquid, there is very small change in its volume, entire volume, or negligible change. So that makes dv to be 0. Hence, this comes out to be 0. So ml is equal to du. That means when process takes place in such a way that solid turns into liquid or melting process, the entire internal energy or the entire heat which is given to a system is used in internal energy only. This is how you apply first law of thermodynamics into various processes.